Hello, so in this video we will see Soql. These are the few points which we will be covering today in this video. Introduction to Soql, where we can use Soql, how we can write a query in Soql, filtering, organizing and grouping the data, and then cross-object queries, that is querying parent from the child and querying the data of child from the parent. So first we will see what Soql is. Soql can be called a Salesforce own search engine, as we can use it to query all the data from the Salesforce database. What Soql stands for? So Soql stands for Salesforce Object Query Language, as it is built to be used on the Salesforce platform. The first via the letter S, and it stands for Salesforce. Then as we are querying the data from particular database, which we call table cell object. So this is the object. And then there is query. Query as in we are asking a question to the database if the particular data exists in it. If exists, we are getting the data. So it is called as Salesforce Object Query Language. As simple as. Where we can use Soql. So many of you must be familiar with the developer console we have in Salesforce, where we can write the Apex codes, see the logs, see the other things like performance or the test coverage and all this. So there is a tab on the developer console which says the query editor, where we can write a query and execute it to get the data in the console itself. Then we can use it in our Apex classes. As you must be knowing, when there was no Soql, we were using the trigger.new, which has only the data from that particular object. And now as we have Soql, we can query whatever data we need. We can query the parents data, we can query the parents related this data, or we can query any data from the org which is associated to this particular object or not even associated object, and we have something to relate with that object. And then there are tools which you can use to query the data, as Salesforce Workbench. Then now we can also use the query builder in Visual Pro Studio. Then there are different tools on Chrome extensions and App Exchange and JitterBitter, Data Loader, and many such tools. And this is the main thing, that how to write a query in Soql. So we will see the main two keywords are select and from. Select defines what columns we need to query from the table, and from defines that particular table. So in Salesforce, the columns are called as field and the table is called as object. So say if you want to query data from account and you want to query its ID, name, industry, so how it will go is select ID, comma name, comma industry from account. One thing which we need to take care of is here the field names are not the labels but the API name of that particular fields, and also for the object name we are using the object API name. The account is the standard object, there are no suffix to it. If say we are using any custom object, then we will be having underscore C at the end of that particular object name. And similarly for the custom fields, we are also having underscore C. Now we will see how we can query the data in Salesforce. I will show you writing a query for the standard and custom object in the developer console itself. You all must be aware of developer console. Here you can see the query editor tab. We will see two ways from which we can define the query. When it's simple, if you know the field API names, as we need the API name for the fields in here, we can't use the labels. So if you know, you can directly type the field names, and the name should be comma separated. As you can see, I added ID comma name. We will use the opportunity object for now, so we will use stage name from opportunity. This is how the query works. You can see all the three columns are queried from the table. Similarly, if you want to query any custom object, you just need to replace the fields and object with that particular custom object you want to query. So I have a TW project named custom object in my org, so I will query some fields from that particular object. So it will be clear how to add the custom fields and how to use the custom object in the query. As simple as we use the fields in Apex, we just need to add the _ c suffix to the field name, which makes the field API name for that particular field. And similarly for custom object also we add _ c. So I have a object and I'm querying ID, name and status from that particular object. So you can see the three columns are queried, and the order of the columns will be similar to the order of the fields you add in your query. The other way you can build a query is you can press Ctrl+Shift+O and search for that particular object you want to query data from. As we have used opportunity, I will show you with account.obj. This will be the account object. You can select the fields you want to query. Just click on the fields and keep the control button pressed from your keyboard. We will select ID, name, type and some few other fields, say billing, street, city, state, postal code, country. So if you click on query, the query will be built in the query editor. Here you can see all the fields are added and also the account, the object itself. You just need to click execute and you will get all the data. Similarly for any custom object you will do the same. Build this for project only. This is project. You will select the fields you want to query. Click on query and execute. So this is how we can use the Soql for simple queries. Now we know how to write a Soql, and now the main thing is to filter the data, as there must be 1000 analogs of records for a particular object and we might be in need of one or two particular records. So we have this where clause similar to Soql. We have where here. So where works very similar to the Soql. We add the field, the operator and the value which we need for that particular field. So say if we are querying on the custom object project and we need the records where the name is test project 1. So we'll add the where name equals to test project 1, and as you can see we have added the test project 1 in inverted commas, as this is a string and name is a string field, so we need to place string to check if that string is there in that particular name field. So let's see in this in developer console. So we'll be adding filters to the same query. We just need to use the where keyword, add the filter we need. We will filter the records where category not equals to null. Click on execute, and you can find we are getting only 3 records. Initially we had 4 records, of which one had the category field as null. Now as we added the filter, we are getting only 3 fields and all are having category populated on them. Similarly, we can add a logic to this query using the AND and OR operators. So we will query only the records where category name equals test category. You can see now we got only 2 records, as the third record has category name as test integration category and not test category. If you change this operator from AND to OR, we will again get all the 3 records, as we are querying the records which have category populated and also the records which have category as test category. So you can see we got all 3 records. If we change this filter to equals null, then we will get the records where the test category is and where the category is null. So on execute, you can find that we are getting the 3 records and the third is where the category is null. Now we will see the like operator. I will add the link for the operators which we can use in the where clause. This we will see this as the last operator. Like uses the fuzzy matching logic. So we will add test at the rate. So this means that if the category name or say the category field contains test as the start of string, the string which it contains, then all those records will be queried. If we add percent at the beginning, then it will check the name if that name contains this test word in it. For now we will add test percent. You can see we are getting all the 4 records, as we are having the filter as category equals to null, so this record is getting queried, and the other was category like test, so the name should start with test, and here as all 3 categories start with test, we are getting all the 4 records. We have seen much of these operators in our console. We have used equals, not equals, then if you have a number, date, then we can use greater than, less or equal. In case if you are searching for a particular list of data, then you can use the in operator and define that particular list in there. Say if you want to find a particular project of which the name is in the list, so you will define in, then there will be a circular bracket and in it there will be comma separated values, and we have seen this like operator also which uses the fuzzy matching logic. Then there is organizing the query. As you have seen, the data we queried was not organized. So say if we want the data in a particular order, or to be ordered by a particular field, to be sorted by a particular field, Then you can use this order by operator, and in this you can order data ascending or descending, whatever you need. We will see this in developer console. For seeing how we can organize the records, we will again move back to our standard opportunity object, as I am not having so much of records to show you how this will be organized. So from this history tab you can go back to your older queries. It has a limit of 10 past queries, and I guess we have reached the limit, so we won't be able to get that particular query back. So I will add stage name, opportunity, we'll just add order by stage name. For adding this, we will just run this query once. So you can see the stage names are random, like first is closed, qualification, negotiation. There is no particular order. So when we add this order by stage name, you can find that these all these records are ordered by the stage name, and the stage name is, as this is a standard pick list, it will be ordered by the values it has, in the order of the values it has. Well, you can decide what the order should be. Now it is, if you don't add ascending, it will always be default the ascending order, and if you need the descending, you just need to add the DSC and you will get the descending order. So it will start with closed one and will end at prospect. This is very simple. This now we will see how we can group the records. So we just need to add the group by operator and the field name for the group column. One thing which we need to take care of is when we use the group by operator, we can't query all the data, we just query the aggregated results. So we will add this as some amount from opportunity group by stage name. So you can see we will get the total amount for all the opportunities which are having the stage as prospecting. Also you can use count, mean, max, average. Here we will add ID. You can add any particular field, string field. So you can see we are getting all the opportunities count for that particular stage. So as I said, one thing we need to take care of when using the group by function is that we will be querying the aggregated results and will be filtering that particular result. You can't query the data when using the group by operators. We will use the same opportunity object to see how we can query the parent data from the child object. As we know that opportunity has account as its parent, this is standard master relationship. So we will be querying few fields from opportunity and then few fields from account. We just need to add the object name, the parent object, place a dot operator and the field from that parent object. So we'll be getting the account name. On execute, you can see we are getting these fields, which are the opportunity fields: ID, name, and stage name. And there is a field which is the account name, which is the data from the parent itself. You can add as many fields as you want. Account.id, account.industry. So you can see all the data is coming. Similarly, when you want to query the data, child data from, you need to write an inner query. So we will query opportunity from account. We will select ID, name, and industry fields from account. You must see that I have placed the comma before the inner query, and then this will be the inner query: ID, name, stage name from opportunities. As you can see, I have added the related list label name. This is the name which we add when we create the master data relationship or the lookup relationship on any particular object. So if you have seen the UI for creating a custom relationship, then you must be knowing that it asks us for the child relationship name. And the child relationship name for account to opportunity is opportunities, and similarly for contact it is contacts. So if you query, you will find that we are getting the opportunity data here. So this is the opportunity data: name, stage name, ID, name, stage name. Only you can see that we can query contacts from account. This is contacts, and it will be a list of the records, the related records. So we have covered everything, starting with introduction, writing Soql, filtering the results, organizing the records, grouping the records, and cross-object queries. So let's summarize what we have learned. Soql stands for Object Query Language. We can query anything, may it be custom or maybe standard object, anything we can query for custom fields. We can also query for the user object, which we can't do in the reports or data loader. Then we can filter, organize, and group the data as required. And the last one is we can use it with cross objects. Thank you for watching, and you can subscribe my channel for more such interesting videos. Thank you.